All right, this video is part 2 of vectors, so let's go ahead and get started. I'm on number 5. They're talking about this airplane flying at course 110 degrees. So here's 90. It's just a little past 90, right? So we'll call it like this. So it flies 200 kilometers on that course. And so from point A to point B. All right, now at point B, he changes course to 37 degrees. So it'd be like this much, right? And he's going to go 100 kilometers there. So not quite as far. We'll call it that much. Find to the nearest kilometer the magnitude of the net displacement from A to C. That's referring to, here's C. It's referring to this blue line. So in order to do this, you're going to need this blue angle. And in order to get that angle, you're going to have to realize a couple things. This red amount was our first course, 110 degrees, right? So if this is 110 degrees, that means this green amount is 70 degrees, 180 minus the 110. So if that is 70 degrees, now you come to B and you put your crosshairs there, like so. This green angle right here is going to match 70 degrees. Okay, now the next thing you need to realize is this red line right here was our second course, and it was 37 degrees. So that means this amount right here was 37 degrees, which makes this entire angle 107 degrees. So now I have the angle that I need, and I can run a law of cosine. We're going to call this this blue line, we'll call it B, all right? So this is what it's going to look like. B squared equals 200 squared plus 100 squared minus 2 times 200 times 100 cosine of 107 degrees. And if you do this correctly, you should get that side as 248.38. So that would be my answer. 248.38 kilometers. All right, moving right along. Number 6. There's some people hiking and they go 8 kilometers on course 30 degrees. So here's the start. 30 degrees would be like this much. So let's go ahead and draw that. There we go. And that was 8 kilometers. All right, now they turn and walk 6 kilometers at course 160. So if this is 180, it's just going to be a little bit off that. All right, so it's going to look something like this. And that was 6 kilometers. And they want to know the net displacement from camp. So here's camp. Here's finish. And they want to know this blue line. So that means I'm going to need this blue angle. And in order to get that blue angle, I have to realize that right from the start, my first course was 30 degrees. That means this amount right here is 30 degrees, which means I go put crosshairs here, and this red amount will be 30 degrees. All right, so now I just need this other angle. We'll call it green right here. So to get this angle, you need to realize that my second course, sorry, I was looking at the wrong problem for a second. My second course was at 160 degrees. This was at 160. That means this whole angle is 160, which makes this angle 180 minus 160, which is 20 degrees. So green is 20 degrees, which makes this full angle 50 degrees. And now I've got a law of cosines where I can go solve for, we'll call this C. I can go solve for C. So it's going to look like this. C squared equals 8 squared plus 6 squared minus 2 times 8 times 6 cosine of that 50 degrees. When you do this, you'll get C equals 6.19 kilometers. We'll call it 6.188 because technically they asked for a nearest thousandth. So that would be my answer for number 6, 6.188 kilometers. Okay, now if you look at number 7, it kind of refers back to number 6. So I'm going to leave this triangle up here, and they're going to want the course to be followed by the hikers in order to return from camp. So they're here at the finish. They want to go back this way, which means you need to find this full angle. So the way you're going to do this is you're first going to realize that this angle matches this angle. So this is 20 degrees. You're also going to need this blue angle, because if you had that, you could just do 360 minus these two angles, and that would give you this amount. So that's the goal. You need to run a law of sines, and you need to solve for, we'll call this angle B. So this is B. So this would look like this. I know C now is 6.188. So it's going to look like sine of 50 degrees to 6.188 equals sine of angle B to 8. And if you do this right, you'll get angle B as 82.04 degrees. So this is 82.04 degrees. So now to get pink, which is this whole angle, I'm going to do 360 degrees minus that 20. I'll keep it color coded, minus that 20 degrees and minus that 82.04 degrees. And if you do this right, you'll get the pink angle as 257.96 degrees. That would be my answer. That one was a little tricky. Okay, let's go ahead and move on. Now we're on number 8. So there's a helicopter taking off on a straight path line. So here's the helicopter. And it's going to take off at a 65-degree angle with the horizontal. So it's going to look like, if this is the horizontal, the horizon, it's going to be an angle of 65 right here. Okay, and then it hovers at spot A, and it's at an altitude of 350 feet. So if it's vertical, this is a 90-degree angle. So if that's a 90-degree angle, you know all the angles of this triangle. This would be 25 degrees. And so you're able to solve this. They want to know the magnitude of displacement from the point of takeoff to point A. So here's takeoff, we'll call it T. They want to know this blue line. All right, so you could do SOHCAHTOA here. I'm just going to run law of sines, though, to stay consistent. It's going to look like this. Sine of 65 degrees to 350 equals sine of 90 degrees, because it's a right angle, to, we'll call this B. Doesn't matter what you call it, to B. All right, and if you do this right, you'll get B equals 386.18. That would be my answer, 386.18. And they're talking about meters, so meters. Okay, moving right along. That one was an easy one. They're usually not that easy. All right, number 9 and number 10. These are the hardest two, so buckle up. Okay, a ship leaves point A and sails 61.1 kilometers at 131 degrees. So we'll call this point A, and it's not going to be going 180, it's going like 131 or so. So that would be my first line. It would look like this. And it gets to point B. And that distance was 61.1. Okay. Next, then it sails 76.5 kilometers on course 36 degrees. So like 36 degrees for 76.5 kilometers. All right, they want to know the bearing of point C. So here's point C from point A. So looking from point A towards point C like that. And I'm going to move this down a little bit just for scale reasons. It's going to look like this. So we want to go this direction. We need to know what that direction is. So here's how you're going to do this. All right, you're going to start by getting red angle, because if you had red angle, you could solve using law of cosine for side, red side. So you need to go get red angle, and here's how. This blue angle was our first course, and it was 131 degrees. So this green angle is 180, right? So this little piece of it would be 180 minus 131, which is 49 degrees. This is 49, which means this green angle is 49 degrees. Now I just need this blue angle, which I can get because our second course was this line, which was at 36 degrees. So this blue is 36 degrees. So that makes this total angle 85 degrees. Now I've got a law of cosine. We'll call this B. I'm going to go solve for this side because I need all these angles. Well, really, I just need this angle right here. But I need to go get B first before I can do anything. So this is a law of cosine. It would look like this. B squared equals 61.1 plus 76.5. Okay, that's the equation you would use, and you would get B having a value of 93.65. So that's this, 93.65. Now, the reason that's important is because now you have a law of sines. So I'm going to use this and this for my law of sines, and I'm going to go find this angle right here, all right? So that would look like this. Sine of 85 degrees to the 93.65 equals sine of angle A to 76.5. You do that correctly, you'll get A equals 54.47 degrees. So this right here is 54.47 degrees. All right, now the reason that's important is because I need to know just this blue amount, right? Because remember what we're looking for. We're looking for the direction of this line looking this way, all right? So I need this amount of rotation. I need to find out what that is. Well, if you remember, the first line we drew was at a bearing of 131 degrees. So this was 131 degrees. So this whole thing was 131 degrees. So if I just take that 131 and I subtract this angle, it'll give me just this portion that I'm looking for. So that's what I'm going to do. I'm going to do 131 degrees, this whole amount. And I'm going to subtract that 54.47 degrees. And that'll give me just this red amount, which is what I want, which is 76.53 degrees, which would be my answer. Ignore the nearest 10 minutes part. This problem used to have like degrees, minutes, seconds, but we took it out and we changed the numbers. So ignore the 10 minutes part. All right, which brings us to number 10. Number 10 is not a fun problem. Well, maybe it's fun for you. I don't know. It is very difficult. So if you get frustrated on it, that's okay. Here we go. There's an aircraft carrier. We'll call it here. And it's traveling on course 204, so just past 180, right? So that's like this way. Let's try that again. Aircraft carrier here, traveling on course 204 at 50 kilometers per hour. So it's moving this way at 50 kilometers per hour. The planes, there's a plane that's going to take off from this aircraft carrier, and it's going to fly on course 328. So here's 270. It's just past that. It's like here. All right. So that's the course the plane's going to fly on, and it goes to point C. So over here, it goes to C. All right. The plane's displacement from A to C, so here's A, is 348 kilometers. So the key that they're going to give you here is they're going to tell you 3 hours later. So remember, we're going 50 kilometers per hour. If we times that by 3 hours, it's going to be 150 kilometers. That's this distance right here. 150. Okay. So this is the triangle that they've given me. It looks like this. So we'll call this B. Now they want the course from point C, from here, in order to meet this aircraft carrier where it was after 3 hours, which would be B. So they want this course right here. So in order to do this, you're going to have to get a lot of information. You're going to have to get a couple different things. First, I would go and I would get this angle right here so that I could get this side right here, and then I could get all these angles. So that's going to be my immediate goal. Now, in order to get that angle right there, here's what you're going to do. All right, you're going to look at angle A, and you're going to need to realize that my first course was 204, which means this angle was 204. Now, red is the 180 marker. So it went 24 degrees past that. That's the first angle you need to get, is red 24 degrees, because it was 204, which is 24 degrees past 180. All right, so that's 24 degrees. The next thing you're going to need to get is this blue angle right here. And you get that because you were told the plane flew at a course of 328 degrees this way. So that means this entire amount was 328 degrees. Well, green, the full circle is 360 degrees. So to get this little amount, it's just 360 minus 328, which is 32 degrees. So blue is 32 degrees. Now that you know those two, you can get this angle, because this whole thing is 180 degrees, right? So you're going to do 180 minus 32 minus 24, which is 124 degrees. I know that was complicated. All right, so I know pink angle, 124. I can run law of cosine to go get this side. That's what I'm going to do next. So that would look like this. We'll call this A. So it'd be A squared equals 348 squared plus 150 squared minus 2 times 348 times 150. Cosine of my angle, 124 degrees. And if you do this right, you'll get A having a value of 449.43. So this over here is 449.43. All right. Now I'm going to go ahead and do law of sines to go get these other angles, because I feel like I'm going to need them. So it's going to be like sine of that 124 to the 449 equals sine of C to 150. You'll get angle C as 16.06 degrees. So this right here is 16.06 degrees. All right, I'm not going to need this angle, so I'm not going to go get it. These are all the angles I need. Okay, what they're looking for, remember, was this direction, looking that way. So the way you're going to get this is by doing this. You're going to need to realize that this blue angle right here matches this blue angle right here. So this entire blue angle is 32 degrees. 32 degrees. The reason that's important is because it goes down to this 90-degree marker, and this 90-degree marker, this whole thing has to be 90 degrees. It has to be a right angle. So what that's going to give me is this green side. 90 minus 32 is 58 degrees. So now I know green angle, I know orange angle, and I know this is a right angle. So in order to do the direction of this line right here, I need this entire angle. Well, all it is this 90-degree angle it's that 58-degree angle, and it's that 1606 angle. It's all three of them. When you do this, you'll get 164.06 degrees. And so you would basically be done, but the thing about this problem is they want it in terms of nearest 10 minutes. What that means is you need to go and take this part of it, 0.06, and you need to times it by 60. If you do that, you'll get 3.6. So it's really like 164 degrees and 3.6 minutes. So if they wanted it to the nearest 10 minutes, that wouldn't even be halfway. My answer would just be 164 degrees. I hope that made sense. That was a really hard problem. But yeah, I mean, that's vectors, displacement, and bearings, and all the fun stuff. So hopefully this video wasn't too confusing. Hope it helped.